Okay, now we can actually go about doing the binomial expansion and expanding any bracket which has been raised to any power or any positive power. Right, so you can see the binomial expansion equation here, and we just learned all about these choose values and how to expand each one. So very simply, these values here are just the choose values, which are the values which we found from the Pascal's triangle, right, or the calculator, and it's just the coefficients in front of each term. A and B represents just any term we're trying to expand, okay? So as you can see, the A term, they decrease in power as we go along, okay? And the B term, they increase in power as we go along, okay? So that's just a rule you have to go for. A will decrease in power, B will increase in power. Okay? And it's just a matter of following this rule. So let's try some examples. So let's say we have 3 minus 2x to the power of 3. So we want to write out everything, right? So our A is now, in this case, 3, and our B is minus 2x. Don't forget the minus sign, okay? It's very important. So first things first is a to the power of n, so n is 3 as well. So it's going to be 3 cubed plus the second term is 3 choose 1, 3 squared, and then we include the b, so it's minus 2b. Let's write it in brackets so you don't get confused with the sign. The third term would be 3 choose 2, 3 to the power of 1 minus 2b all squared. The last term would 3 choose 3, and then minus 2b to the power of 3, like this. Okay, so it's just a matter of following this formula. And then we just simplify it. So we'll get 27 minus 54b plus 36b squared, and then minus 8b cubed. All right, okay. Oh, sorry, this should be x. Sorry, this is x, right? So these will all be x terms here, like this. But the rule just applies. As long as you follow the formula, then you can expand it, anything. Let's try another example. So let's try 1 plus x over 2 to the power of 4. Okay, so in our case, a is 1, our b is x over 2, and our n is 4. Once we've identified that, it's just a matter of following the formula as we just said before. So we have 1 to the power of 4 plus 4 choose 1, 1 cubed times by x over 2 plus 4 choose 2 times 1 squared times x over 2 all squared plus 4 choose 3 times 1 times x over 2 all cubed. And the last term is 4 choose 4 times x over 2 to the power of 4. Now it's just a matter of simplifying it. So you get 1 plus 2x plus 3 over 2x squared plus x cubed over 4, no, over 2, sorry, plus x to the power of 4 over 16. Okay, so these values you can just find or plug it into your calculator. Yeah, let's just try maybe one more. So let's just try x plus 1 over x to the power of 5. Once again, as long as you identify what a, b, and n are, then it's the same rule. So a is x in this case, b is 1 over x, and n is 5. So we get, the first term is x to the power of 5 plus 5 choose 1, x to the power of 4 times 1 over x, plus 5 choose 2, x to the power of 3 times 1 over x squared, plus 5 choose 3, x squared times 1 over x cubed, plus 5 choose 4, x times 1 over x to the power of 4, and the last term would be 5 choose 5, 1 over x to the power of 5. And now it's just a matter of simplifying it, so you get x to the power of 5 plus 5x cubed plus 10x plus 10 over x plus 5 over x cubed plus 1 over x to the power of 5. Okay, so as long as it doesn't matter what a and b are, right? It can be any big numbers, it can be x's. As long as you follow the rules, then you can expand it all.